Hello, my name is Peter Rigney, Projects General Manager for the Northampton Generating Company. Northampton Generating Company consists of the Northampton Generating Plant and the Northampton Fuel Supply Company. The fuel sites we'll be visiting today are located approximately 100 miles due west of New York City or 85 miles north of Philadelphia in the northeast corner of Pennsylvania. The Northampton Fuel Supply Company obtains waste coal throughout northeast Pennsylvania and supplies it after processing to the Northampton Generating Plant for the generation of electricity. Waste coal in northeast Pennsylvania is a result of mining practices which over time have improved but have left millions of tons of waste coal. This waste coal is either considered gob in western Pennsylvania in the bituminous region or culm from the anthracite region in northeast Pennsylvania. The Fuel Supply Company has processed 10 million tons of waste coal. Each day, 108 trucks transport the fuel and ashes used for the reclamation of the fuel sites, which is then returned to a benign state. The impact of waste coal in Pennsylvania covers an area of 250,000 acres, or 101,000 hectares. The Northampton Generating Company can not only burn waste coal, but can also burn alternative fuels. And alternative fuels can be anything from tire-derived fuels, chipping of old tires. Additionally, there's petroleum coke that can be burned. It can also burn wood waste, which is produced from the chipping of wood pallets and construction debris. In 1996 and 1998, Northampton Fuel Supply Company received the Governor's Award for Environmental Excellence. Additionally, in 1998, they received the U.S. Department of Interior Office of Surface Mining Award for Reclamation Excellence. In a moment, you'll hear from Mr. Jack Egley, Fuels Manager, who will discuss the details of the fuel sites that Northampton uses, along with the process for bringing fuel from waste coal piles to the power plant for the production of electricity.
It's anticlimactic, and at first that used to disturb me. Then I came to realize that's what's supposed to happen. That's what it should look like. Whenever you're going to locate into a site you have to get all the necessary permits, and typically you'll use an engineering consultant to help you with it. There's a great deal of paperwork, there's a great deal of testing, documentation that has to go into it beforehand. I know one of the things that's popped up recently is bat habitat, and I'm talking about bats that fly around at night. Also, you have to do groundwater monitoring. You know, there's been so much old mining in this area that the water is negatively affected, and sometimes it gets very difficult to prove where the water's coming from. You know, is it from this site or is it from the neighboring site? And guess what? At the end of 2 to 5 years, you may not be issued the permit. So you can't put all your eggs in one basket. You know, in this business, if you're not looking 10 years or more down the road, you will be blindsided. Before 1977 in Pennsylvania, there were no environmental laws that regulated how the coal was disposed of, and the result are some massive waste coal piles. This material is highly acidic. The resulting water that runs off is termed AMD, acid mine drainage, that present a continuing and ongoing problem for the environment for the local communities. You know, it's kind of funny. One of the things you run into when you're permitting one of these sites is the local neighborhood, they want rid of these piles. They're relatively supportive of the whole process until it comes to the trucks. One of the most efficient ways to haul bulk material is to keep those trucks loaded both directions. Whenever you have to go a three-legged haul, and by that I mean the fuel comes from point A, and in an ideal scenario it goes to point B, the ash gets loaded at point B back to A. The worst case scenario is whenever C gets involved and they have to go off route, they have to go to another place to take the ash, then deadhead, and that's a term for running a truck empty. You have to deadhead to a site. So that's all part of what you look at. PennDOT allows up to 80,000 gross vehicle weight. With the proper road conditions, we're allowed to haul 95,000 pounds. Doesn't sound like a lot, but you have that incremental cost involved. The truck's already making a trip, and they really don't use any more fuel or very little more fuel to haul 95,000. than they do to haul 80,000. And of course, it also cuts down the number of trucks. There's about 20% fewer trucks when you can haul 95,000. Many roads, they're limited to a 10-ton limit. You can get a road bond. And in Pennsylvania right now, you have to post $12,500 per mile. Then every 6 months, a PennDOT inspector will come out and take a look at that road. If they deem that you've done damage in excess of what the normal routine traffic would have done, you're obligated to either fix the road or forfeit the bond. And of course, if you forfeit the bond, they'll take your money, but you won't get another permit. The majority of these sites, none of them are located really close to the power plant, so there's always a lot of transportation involved, a lot of trucks. And of course, that's one of the reasons for the blending and beneficiation process that we use to minimize the trucks, minimize the number of trucks and the cost that's related to those trucks. The least expensive thing you can do short of putting the material on a truck is to dry screen it. You keep the material dry, you keep the BTUs where they need to be, and you can actually overwash. It's a weighted average blending. If you have 8,000 BTU material and 4,000 BTU material, if I put them together, presto, you've got 6,000. In the end, we're hauling BTUs. That's what it's about. We use the coal preparation plant to separate by specific gravity the better quality material from the lower quality material. And many times that will allow us to be able to directly blend a widely varying mix of fuels. Well, as it turns out, that plant's got a lot of flexibility. Not only does the plant have a lot of flexibility, the individuals that operate the plant have a lot of flexibility. They're pretty entrepreneurial. They were able to utilize a lot of different processes or a lot of different products. In the past, Northampton has burned paper pulp, and I can tell you, they're always looking for more. This machine, the CFB itself, has the ability to burn a widely varying fuel spectrum. It could be wood chips, demolition waste. Those other fuels can also be things like TDF, tire-derived fuel. They're tires that have been, they've run their life, they get shredded, and it's pretty valuable fuel because it's high BTU. What it does is allow you to burn some lower quality material and better utilize your reserves at sites and stretch your reserves and stretch your dollars at those reserves. And that's a big part of what happens here. It's important to understand the characteristics of the POW, to blend it properly, not only to give that product to the plant that they need, but also to do it in a cost-effective manner. That's critical. The fuel that's produced from this site goes to Northampton Generating, to the CFB unit down there. Limestone is introduced into the combustion process, and that's to capture the sulfur. So there's a lot of unreacted limestone, 22 to as high as 28%. And then the resulting ash comes back to the site as part of the reclamation process. Because it's part of a recycling project, you're getting the electricity from an otherwise waste material. Emissions controls are stringent, and even though the EPA and DEP regulations keep drilling down and make it more and more challenging, more and more difficult, and more costly too, for the most part, the CFBs kind of take it in stride. Now, thanks to the work that was done there, it's got a lot of potential. This has gone from a liability for a community to an interest or tax generating property. It could be job creating industrial park. The Uber site now has a Pennsylvania Department of Transportation facility on it. The first site we did, the Kaminsky site, it's in the hands of a developer right now. So, the process continues. Then eventually you're going to run through the entire POW, and you're going to be faced with a pretty formidable task, which is to pick up the operation and move it to another place. Everything, and I'm talking about from the preparation plant itself right down to the porta-john. Everything has to be packed up and moved. The plant that we're running now is designed to do that. It's modular. It's made to Actually, the building itself, the housing is almost like a can sitting over top of the equipment. The equipment isn't part of the building, and the converse is true too. While the plant's still operating, the building will be dismantled, put on trucks, moved to the next site. Then once you're finally ready to pull the trigger and move the plant, and it's a big day, you shut the plant down. You've already got your infrastructure ready at the next site. You've got your electricity in there, your water, all the stuff that has to be in place. That's all been done. One of the facets of the design of this plant was to get away from permitted loads because it brings a lot of other complications with it and cost. A non-permit load means that you can just put it on the truck and the truck doesn't have to do anything special. They can just go there. And of course you dismantle from the top down, and when you get there, that's not how it goes back together. The last component that got put on a truck is the first component that you need to re-erect the plant. So it takes a lot of orchestration. Of course, then once you get to the new site, they'll begin to erect the plant, they'll put all the components back together, and usually we're always moving, we're always trying to get back in production. Even before the building is completed and put back over the plant, we'll be running coal. It takes a great deal to make all that happen too. It's not an easy process, it's a challenge. And I always like to think of this as the ultimate recycling process. You have a waste product that's here that's harmful to the environment, harmful to the people living around it. We get to utilize it, create a number of jobs, make some money. And I think Northampton has done a good job. They figured out, they do what they got to do to keep things running and do it in the most cost-effective, efficient manner they can and utilize all the fuels that they can.